Hey,
Hello.
hello. Welcome to our Customer Connect webinar for October. Thanks for joining. See, we only have one right now, so I'll wait exactly 2 minutes to let anybody else join in. And if nobody else does, we'll go ahead and start without them. Maybe just as we wait a couple of minutes, I just want to say that, we are recording this webinar, and so the recording can be found on the website afterwards, and I'll show where. Um, it's in the student resource portal is what we call it. And so I will just show that really quickly that if you go and log in and you go to the top right drop down, we have this one called student resources, and in there, once it loads, you can see we have a webinar recordings tab. And so we've been putting all of our Customer Connect webinars up here, and even the registration form is there. So at any time, you can always register for the next event. And so we do these monthly, first Thursday of every month. And, we're encouraging to ask questions on the registration form. I know nobody likes asking questions or talking webinars. So I've put a place where you can put questions and comments on the registration, and then I'll cover them in the webinar today, or sorry, in the webinar. Um, so yeah, and we have a couple questions to go over today. And then every session we're only doing them half an hour to make sure that they're quick and easy, and there'll always be an included demo, and then we'll answer all the questions from the registrations, and then we'll open it up to QA. So we have it booked for half an hour, but if we ever have where there's more and we have a great discussion going, we can always go further. And so I'd love for anybody to just spread around to any Simac users to come and use this Customer Connect webinar to learn how to use Simac or how to make your day-to-day life easier working with Linax. Okay, so I think that's good. Okay, we got a couple more joining in, so I'm just gonna get into it. So today, the included demo that we're gonna look at is using FFF or flattening filter free beams on Simac. So, as stereotactic treatments become more popular and machines continue to be made flattening filter free, it's an important topic that not many get exposed to early in their training. That CIMAC can really provide that training in that content for any programmer or any individual, really. So first, I'll just show you guys how we create an FFF beam and then actually show that it is giving FFF results, which would be looking at the dose rate and looking at our flatness, right? So I'm going to do it on the Magnetron or our Electa simulator today. I think I mostly use the Klystron, so I'll do the Electa simulator today just to show that it is, the same. And so when we're here, we're here in our Magnetron traveling wave simulator. And I'm just going to reset to defaults just to let everybody know that the simulator always remembers your last state. So sometimes when you come in, it can kind of run some funky things if you didn't have all your parameters set, or you have been messing around with some parameters. So anytime you want to reset to default, you just click to another default energy and then click back to the default energy you're looking for, and that'll reset all of your default values. So I'm just resetting to a default here of 6 MV, and I'm gonna run that, and then we'll look at our flat one, and then I'll show you how to set up an FFF beam just to ensure that we have a good default set here. And then what I'll do even is I will save this state, and we'll call it let's just call it October 2nd flat. So here's our flat one. And so that's run. And so I can save that state. And then we can just confirm that our October 2 flat is there. And so now we want to run an FFF beam. And so where we're gonna go, and I'll just show you guys in steering that we do have a uniform flat beam here for a 6 MV. And then to get a flattening filter free, we go to our treatment head, which makes sense. And then down at the bottom here, we have a flattening filter free flag or FFF flag. And all we have to do is we have to select that flag, and then we can rerun our simulation of a 6 MV flattening filter free. So we're going to run that. And I think the first thing I'll look at is we can go to, or why don't we stick at the profiles here? And so immediately we can see that this is, exactly representing an FFF beam. So very peaked in the middle and with a lot of unflatness. And so you can see how you'd be able to use these plots to really explain stereotactic treatments and why we use such small fields and how that gets us that high dose rate. And then looking at our dose rate, we can see it went, from around 320, I believe was the first one, to now around 950 centigrades per minute. So very much like you would expect from a flattening filter free beam. And so there's that part to investigate. And then I just wanted to then show you. So then what we can do is we can October 2nd FFF. We can save this state, and now we have both of our states here. And what we can do is we can actually go to our water tank, and I'll do our flat one first. Let's do our October to flat, and we'll do a depth dose. And just to I just want to show you guys that we can also look at the beam softness, checking out beam softness compared in our flatness or our flat beams and our FFF beams. So now we're running the water tank scan, and that's perfect. We got our run out, and then we'll select our FFF beam now, and we'll call it October to FFF. Again, we'll do a depth dose scan and run experiments. And so I do also just kind of want to show as I do all these demos, just kind of, like the normal use of the simulator. So I wanted to make sure you guys saw setting the defaults and running the water tank all the time. And then we can look at these side by side, and we even get our D10 over D20. So you can investigate, or you can explain why an FFF beam would actually become softer than a flat beam because of the beam hardening done from the filter. And so you can check that out in our D10 over D20. And then you can actually even in our steering and our treatment head, we can export to CSV, and the values that you get out are open this up, are the dose per pulse at 10 centimeters, at 20 centimeters and 30 centimeters, or whatever distances you had selected, I should say, and then the distance. So then you can use these values to calculate, different values to compare versus a flat and non-flat beam, and then use these values to actually confirm that we've calculated our values correctly and things like that. So that's kind of in general, that's just like the quick FFF beam. And so I'll do it over on our Klystron side just to show, quickly again. I saw a couple people coming in late. So again, we shift between our default energies to make sure we set all of our defaults back. We will run just a regular flat beam, and we'll check out the dose. We'll check out the profiles. And then we'll go to our treatment head, because that's where the flattening filter free parameter is, or the checkbox is. And then we can run a flattening filter free beam. So there we go. So we were in defaults and nothing changed. And then so we can go to treatment head again. We can look at our flat beam. We can select FFF flag. Whoops, FFF flag. And we can run simulator. We'll watch our profiles change, and we'll go check out our dose rate as well. Of course, if anybody, has any questions or wants to interrupt and look at other things, please feel free. Happy to discuss. So there we see now we picked up all our unflatness, and then we come back to Simac, and we're getting, a double dose rate of almost 600 centigrade per minute. So definitely something we can do is investigate these FFF beams, and then I only give an example of, I did do on both machines, but you have both machines, you have 3 energies, and then you can start looking at things like in your treatment head of different SSDs to find different values of, for quality assurance and whatnot at different field sizes and all of that. There's lots of different parameters you can change to look at different FFF beams to really understand why the beam is getting created the way it is, and why taking that flattening filter is getting the results that you're seeing. So yeah, so that's great. So that's our included demo of the FFF beam. And so we did have a couple questions from the registration that I did want to go over. So the first question was from Aaron Gopal. So thank you for asking. And he just asked about tips on using this for resident training, including a sample list of demo items to use as a checklist would be great. And yes, that would be great. And we're really, really working to kind of create these documents because we have a ton of content and the simulators are difficult. So we want to have a map that's one to one of these programs so that you guys can get this our package, say these are the modules we want to learn, and then just assign that to students or trainees. And so what I'll show you is what we do have right now, and it'd be great if we could maybe get some feedback or I can make some suggestions of what we can do. So first we have what's called a lesson guide. And so this lesson guide, it really shows how to combine our textbook content, quizzes, labs, and exercises to teach specific topics. So we have three. We have one made for basic accelerator theory for medical physics students. We have one for quality assurance of linear accelerators for medical physics residents. And we have maintenance of linear accelerators for medical physicists. So kind of just like look at the residents, what you'd see here, right? Like something like this is, I think, one of our most popular with our customers is our beam dosimetry and PRF2 lesson. And so what this tells you to do is to look at the Linac calibration lesson. So just to, kind of show everybody. So that would mean we'd go to our course space and our Linac operation theory, and then we would find our Linac configuration. Or sorry, what was the Linac calibration? Oh, this I believe is actually going to be in our quality assurance. And we would find our Linac calibration. Hmm, this is, I should know where it is, I guess. But yeah, we would find our Linac calibration, sorry, lesson, our topic here. And so we would get the students to go through these chapters after Linac calibration. And then they could also do the beam, dosimetry, and PRF quiz, which all the answers to all the questions can be found in the text. We've made sure of that. And so these are, multiple choice questions. So how many, elect and it does do elect and variant specific questions. So that would be the chapter you would go through, and then we would do lab 21. And so we go to our lab section, and what's lab 21 is relative output factor and profile dependence on field size. So then it gets the student or trainee to do this lab, which here we're looking at. I believe we might have looked at this at another webinar, but this lab, all our labs do is they isolate the simulator, give you one or two parameters to adjust, and then allows you to see the real time output of that. To just understand some things like right here we're looking at your output factors dependent on your field size. So when we increase our field size, what happens to our profiles? And so you can kind of see that kind of instantly without a lot of complexity of using a full simulator in your way. And then it takes them through a set of questions to really make sure that they are, understanding the phenomena or the procedure we're trying to teach. And then on the instructor side, they can actually see those responses and give feedback. And then, we say the lab is to do the TG51 simulator, which would be to do a TG51 test, right? And so then we have our TG51 simulator, and you would go there and you would get the students to perform a couple TG51 calibrations, and you could do it with different machines again, with different beam energies, and with different MUs. So there's lots of different things that you can do with just one simulator, right? There's always multiple machines and multiple beam states that'll get always, slightly different results, but they'll always be relative in the same ways. And these are the ways we find our customers really allow their students to understand the topics that they're trying to teach. So it's kind of so it's like that. So that's what we do have for the lesson guide, and this can be found again in the student resources. Let me double check that actually, because it might only be for certain people. because if it's not available to everybody, I can make sure that it's available to everybody because I believe it's actually right now only available to the institution managers. So what I can do is I can make that into our general one and I could just put a platform module guide or something like that, and I could upload that for everybody if we thought that was useful. I think I'll do that regardless. But I'd love to hear if there's any feedback on that document, if that would align with what people are looking for, if they're looking for more. But I will for sure get this on the platform for everybody to have access to. And that's great. And then the other option and I'll just show you, I mean, we have things on photon beams, the Linac configuration, beam steering, and then up in the kind of the theory, we'd look at, electron beams, waveguides, photon beams, and again, the config. And then kind of looking at the maintenance, again, we're talking about waveguides, electron beams, the configuration, beam steering, klystrons, magnetrons, modulators, waveforms, and beam dosimetry, kind of in the aspects of maintenance of linear accelerators. So we have lots of great modules that we believe and we do have our customers use, and it just really helps understand or make it very, very simple of what pieces of our material to combine to teach specific lessons. And then the other thing that we just worked on this, and I'd love to get some feedback and make this available for everybody, is the learning objectives from the Camp App website that Simac can cover. So we went and scoured the Camp App website and some other programs websites that produce the curriculums that they're teaching their students. And so we condensed that into a big list. We went through them all and then just kept the ones that we can cover in Simac. So, looking at fundamentals, safety, and systems, talking about explaining overall architecture of a Linac gun, exploring differences between photon and electron beam generation, recognize common hazards, explain basic mechanical tests such as, gantry collimator, couch isocentricity. Glad I pronounced that right in front of everybody. Reference dosimetry, so talking about outline the setup of and perform a TG51 photon reference dosimetry. And then routine Linac QA, identify approaches to Linac QA results, including out of tolerance findings and returning systems to service with appropriate documentation. And then clinical operations and troubleshooting. So getting a little bit, there is some things that cover a bit out of scope of the Camp App, but this is in general, these are the topics of Camp Ep that we can cover directly. And there'd be some other things we can cover, supplementary, but these are the main ones that we really can cover. And so I am working on getting this up on the website on the pricing page, just so when people are looking at the product, they can see this. But at the same time, I can this is something that can be shared to anybody. We'd be happy to share with anybody to I don't know, either understand what they can teach with it or learn some new things that they can teach with it. And maybe I can get it up into that student resource portal as well. So that would be I think great. Okay, yeah, so that was the question around the residency stuff. So that's what we have. So, if anybody, feel free to shoot a message later if you had any feedback on that, or if that wasn't aligning with what, would be the most ideal thing to provide to everybody. But that's great. Thanks for asking that question, Aaron. And then we have a question from Mohammed, which great. Thanks for asking, Mohammed. Mohammed took our service courses a couple years ago, so I'm glad to see you're still interest in Linax, and he asked, "What is the purpose of beam steering during the electron gun replacement process?" And that's a great question, and really, it's going to be like that. Your beam source is being altered, right? So when you get a new gun in your Linac, your old gun is probably it's going to produce your source just differently because it's a very delicate thing, right? Our filament current of producing electrons to inject into our waveguide. So every time you change a gun, they're not going to be 100% the same. And so you're going to have to first, your beam source is going to be different. So you're going to have to calibrate your guide, your steering magnets in your waveguide. And the reason it's going to be so important is because if you don't, you're going to damage your parts. Um, and so in fact, our simulator can actually simulate that pretty well in the sense that so we have our filament voltage here, and generally when your gun ages, the source doesn't produce as much source, or it does we don't produce as many electrons, so your filament current actually decreases. Um, and sorry, I'm just looking for filament current. I know we have it. It should be. Oh, maybe. Oh, sorry. Yeah, sorry. I was just because obviously the Klystron doesn't have the same filament current that the magnetron gun does. Um, but if we were looking at our magnetron and our filament currents, as guns get older, our filament current would tend to decrease with aging, just to do with just to do with honestly with aging, that it's just not working, performing as efficiently as it was when it was first created. So our filament current starts to go down, and so if our filament current kind of ran out to 7, um, or maybe 7.5. Oop, it's not liking that. Oh, it's because I'm running with a flattening filter free on. That's absolutely why. Um, Let me run a default beam here. But just kind of going back to what I explained, your filament current will go down, and so you could really simulate an old gun with having your filament current decrease, and then we'll see some asymmetry in our profiles. And then so what we would do is we would calibrate our steering coils to our reduced filament current. So now our system is calibrated to our old gun. So now let's go back to our default gun. That's our new gun. And then you'd have to recalibrate your steering coils again. So that's something very much, that's something that Simac can definitely demonstrate and have some use in providing some hands-on practice and experience with that. Because then if we were to run this down, it's really not liking that. That's disappointing. Sorry, guys. Not really sure why this is failing on me. What if we raised our filament current voltage over on our Klystron? So that did run, I believe. It's running no beam. Okay, so obviously I'm a little out of date on my parameters, and I guess I'm running some parameters that are just making the beam fail. But as a service engineer or somebody who is in that position, we could definitely find those values that were a little bit closer to the ones that would create that asymmetry and then allow you to kind of steer it back to normal, right? Because what I will show you, what I can at least show you is, the steering factor of things is definitely a usability of Simac. So. But that is the last question we had. So I did our flattening filter free demo and I kind of answered our questions. So hopefully that was, sufficient and useful and helpful for people using the platform. And I'll happily open it up if anybody has any questions or would like to see any demos or curious if we can do anything on Simac. That's really what we're here to do, is like if you're looking to do something on Simac to train or to practice, research, that's what we want to help you out with, because the simulators are very complex, just like the linear accelerator. And so we want to help you guys be able to use them. You have anything in the chat there, Adelina? Just my note taker.
Yeah.
Nice. Okay. Well, if there's no questions, I won't keep everybody. This is another part. I'd like to keep these webinars short and sweet. So I know everybody has busy lives and busy work schedules, so I don't want to keep anybody too long. And like I said, this recording will be available. And please, I hope to, thank you very much for coming today. It's great to see a couple faces and have our webinars get a little bigger. And then hopefully we can see you guys again next month. And so remember, it's the first Thursday of every month, same time, 2 o'clock Eastern time, 11 a.m. Pacific time, doing half an hour. And then don't forget, let everybody know, use the Simac. Nobody likes talking in webinars, so just ask me the questions on the registration form, and I'll make sure to do the demos and answer the questions live on the webinar. And I'll hang out for 5 minutes if anybody wants to talk or ask any questions. So
No, thank you very much.
yeah, no problem. Thanks, Yannick. Thanks for joining us.
Thank you. Okay. Bye
Yeah,
bye.
thanks, Mohammed. Great to see you.
Welcome.
And Aaron, it's great to see you. Oh, he's gone.
Hello. Hello. Am I
Hello.
audible?
Yeah, I can hear
Yeah,
you.
hi.
How
Yeah,
are you?
Satyam this side. I'm good. Yeah,
Thanks for
actually,
joining
I'm
us today.
nowadays, actually, I'm using this software, Plimo,
Yeah.
to simulate my own Linac. Okay. So I'm generating the histories. It is basically based on the Monte Carlo calculations.
Okay.
Okay.
Is
So that
ours?
is no, not yours.
Okay. Yeah.
Not yours. So Primo allowing me to do the theoretical calculation of the
Yeah.
electron transport,
Yeah.
and I'm just comparing with that theoretical calculation with my experimental data, what I
Great.
am observing on my Linux.
How
Okay,
is it going?
actually, I'm facing I'm not. I don't have a much high-end system to
Yeah.
perform the simulations.
Yeah.
So that is a different part. So I'm trying to collaborate with some other institutions to get a high-end systems to run that.
Okay.
So
Would you
my
be?
basically point is, can I use the CMAC for my own research, like comparing the theoretical data with what we observed in theory with the experimental data,
Yes, we would. We
and
would.
it will allow me to simulate my own Linux
Yes,
because
absolutely it will. That is the we so this version I will say clearly that we only are within 5% accurate to a real Linac. So I
okay.
can't guarantee that it's going to get you exactly what your Linac has, but we would say within 5%. But we do believe that we've included all the parameters necessary to replicate your machine.
Yeah. If that option in future is available, then we can go for few publications on that basically.
Yeah, that would be like
And
amazing. We
that
would love to see that as well. Um, so yeah, why don't you? Instead of having this convo on the webinar, why don't you just shoot me an email and I would totally be happy to talk to you about getting you some access to this simulator.
yeah, sure. I mail you.
Yeah, shoot me an email, and I'd love to hear more about what you're actually looking at too, because this would be that we would love to have somebody use Simac to do some research and have some published results. That would be great.
Okay.
Okay.
Also, along with this, I'm also trying to use this Flare, this CERN also providing free Monte Carlo calculations of and this Flare GUI.
That's
So
great.
that also I'm nowadays
That you
exploring.
Yeah,
Yeah,
that's
I'm
great.
still
That,
in
did you
learning
say?
phase, not an expert, but I'm still in learning phase, so I'm learning in that direction.
Great. That's awesome. And where are you from?
I'm from India.
Great. Amazing. We'd love to. We'd also. I mean, we've sold to a couple of people, or we've worked with a couple people in India and in Bangladesh now, but this is very new to us, and I'd love to learn more about your guys' training and needs over there. And I'd love to work with you on that research that you're working on.
Yeah, it will be interesting to work with you.
Very interesting. Yeah. Okay. So we'll connect. We'll connect after this. And
Yeah,
yeah,
definitely.
yeah. Shoot me an email, and I'd love to discuss.
Sure.
Okay.
Thank you.
Anything else you want to talk about now?
No, thank you.
Okay, amazing. Thanks for joining us today. Is it Satyam? Is that how you say it?
It's Satyam.
Satyam. Did I say that right?
Yes, it is correct.
Satyam. All right, great. Thanks for
Yes.
joining us today. Take care. We'll talk
Thank
soon.
you. Okay.
Okay.
Thank you.
Goodbye.
Bye.